I find the exchange intellectually intriguing and very practically useful for my everyday research. The exchange with the leading technical stuff of software AG helps me calibrate my research from the point of view of real world needs. And the exchange with some of the most renowned colleagues from different areas of computer science helps have or take a broader view on various topics that we discuss. And we discuss very interesting topics related to software industry. One of them, for example, was the effect that large language models are being currently developed will have on the software development processes. Another topic was the effect that probably the EU Data Act will have on the software industry, and many more topics like this, which are directly related to my research. Good and timely questions. Indeed, the eloquence with which large language models produce text or even generate code, or recent developments with, for example, the GitHub's Copilot, have the potential to radically revolutionize the software development. To the point, they are fascinating to the point that people are predicting the end of programming. I don't fully agree with this. I think, if at all, it will be the end of programming as we know it today. Indeed, once these large language models or code models become commodity, we will see a new style of programming, which some people call conversational programming, coming up. The idea is here that the language models produce code in interaction, in conversation with humans. Nowadays, our integrated development environments are focused around the human, make the assumption that it's humans that produce code. In the future, they will be kind of organized around human plus AI. And we will have the human kind of in the role of telling the machine what the human needs, what the software developer needs. This task will be the task of software developers. So we still need software developers. And they will do this telling in some programming language if you want. And we will see design methods coming up to make this telling more efficient. Second, we will see, I believe, very radical changes in the way we think and design DevOps pipelines. These will also consist of AI-based components that in conversation with humans do, for example, testing, verification of the code generated by AI machines. Third, complex software will probably be composed of components that are modeled explicitly, are implemented explicitly, and components that are generated by AI. And it requires software development skills to manage the complexity of such software. And finally, we will certainly need software developers, highly skilled software developers that implement new models if we don't want to rely and be dependent only on few actors in the world, few big tech companies to produce these big, large language models. There are two directions in my research that contribute to reducing the energy costs of IT. In the first direction, I work on programming support for decentralized data-driven software. Instead of having data be replicated, be moved to centralized clouds and data centers, the data stays where it is, and it is the computations that go to data. This way we avoid duplicating the data, which means at the same time duplicating the infrastructure, the data centers that we need for storing, managing, processing the data. And hence, if we avoid having to build more and more data centers, we also avoid their CO2 emissions, which are quite significant. And then we can also utilize existing computing infrastructure that we have, but currently is mostly idle. I'm talking here about our very powerful mobile devices or the very powerful, often devices that we have on the edge of the computing infrastructure. The second direction is about designing ways to do neural symbolic learning, and especially do neurosymbolic programming within the Hessian Center for Artificial Intelligence. I collaborate with colleagues to design such languages, and the hope here is that by combining symbolic reasoning and learning methods, we will need less this huge models that have huge amount of parameters that need to be trained and which consumes a lot of energy. I don't think that low-code or no-code platforms are only for non-IT persons to develop toy applications. As far as I know, Software AG recently bought a company that provides a low-code or no-code platform for streaming, data streaming and programming data streams. And I know of startups that are building low-code platforms for developing ERP software. The idea is to enable domain-specific specialists to build their own ERP software. Now, none of those is kind of about non-IT specialists. And the first one is not about non-IT specialists, and the second one is not about toy applications, it's about complex software. Now, the trend of low-code, no-code, while being very popular nowadays, is basically not new in computer science, because during the whole history of programming languages, the goal has been to raise the level of abstraction, so to reduce the amount of low-level code that developers have to implement. And if you want, the low-code, no-code platforms have their roots back in the 90s, in the fourth generation of programming languages, in visual programming. It's just now that it's kind of being more and more popular. Now, the key for enabling these low-code and no-code platforms are domain-specific languages, which again kind of tells this story that PL has always been about providing ways to implement software with less code. Now, to the question as whether very complex software, business software, can develop exclusively by using these low-code and no-code platforms, I'm not sure about this, because a complex business software requires very expressive notations, and domain-specific notations, domain-specific languages are great for what they are, but they are typically difficult to compose. So I see the future rather in low-code, no-code platforms being developed on top of programming languages that enable easy embedding of domain-specific languages, which by being embedded within the same language become easily composable. And this way we can compose different domain-specific languages that address different concerns of a complex software.